Good afternoon, ladies and gentlemen. My name is Iman Badr from Helwan University, Egypt, and I would like to present to you my paper entitled Integrated Scheduling for Make-to-Order Multi-Factory Manufacturing, an Agent-Based Cloud-Assisted Approach. Let's begin with a short motivation. As you all know, the manufacturing industry is undergoing an industrial revolution, the so-called Industry 4, characterized with mass customization, where customers around the world can place their orders and have their customized products delivered to them at low prices. This is enabled due to the higher integration of manufacturing facilities distributed around the world and producing the same manufacturing services with competitive prices. The challenge in this visionary environment is how to optimize the production flow of customer orders in a way that provides customers with the best prices and time to delivery. And to deal with this challenge, the presentation is organized as follows. First, the problem is analyzed, then the scheduling architecture proposed in the work is overviewed, then the scheduling method is described briefly and illustrated. Finally, the paper is concluded with some remarks and future work. Let's first start with an analysis of the problem. In order to analyze the problem, let's consider how a customer order is placed and satisfied. In this case, the customer will have to place his order to a manufacturing platform, which decomposes the order into services and can locate for every service candidate facilities providing this service. For example, different factories will be available for manufacturing parts constituting the required product, and one of them has to be selected according to the required criteria. Then the unfinished, like for example the lowest price or the best delivery time and so on. And then this unfinished product has to be shipped somewhere, possibly to be assembled, and there will be also candidate shipping means, and one of them has to be chosen. And then we will have again, or this platform has to choose one of the assembly services, and so on until the product is packaged and transported and delivered to the customer. So you can see from this analysis that the product's cost and time to delivery are highly affected by the selected production flow, which raises the question, how does the production flow of a typical workpiece look like? So let's first analyze this production flow of a typical workpiece. It consists of a set of steps, starting with the collection of material, which may be transported to a factory. This material can be transported for a factory where it can be transformed, i.e. processed with different steps until parts are produced from this factory and possibly transported to another factory, and these two previous steps are repeated until the finished product is produced and possibly stored temporarily before it is transported and delivered to the customer. So the time or the real-time planning of a production flow is the concern of manufacturing scheduling, which is defined as the allocation of available production resources over time to best satisfy some set of criteria. For such a dynamic and distributed environment, scheduling has to be tackled out of an integrated view, accounting for the entire set of production flow steps. Accordingly, the steps are analyzed in this table, where the resources of each step are identified. To reduce the complexity associated with tracking this overwhelming set of resources, i.e. identifying an agent for every resource, the influencing entity is identified for every step to be modeled later as an agent undertaking the allocation decision for the corresponding step. So for example here, the material collection step. For this step, the material supplier is responsible for allocating material to a given customer request, and for the transportation step, the shipping company is taken as the allocation responsible or the influencing entity. Similarly, for the transformation step, we have different resources such as CNCs, robots, AGVs, but the factory is viewed as the influencing entity. And for the warehousing company is conceived as the entity in charge of allocation. And finally, it is clear that for customer delivery, the customer is the one responsible for taking delivery decisions. And for these steps, we have influencing factors, static and dynamic. Static factors such as the maximum speed of a truck, for example, or the capacity of a truck or of a warehouse. And also dynamic factors that change with time, this correspond basically to the current status and schedule of the different facilities. So here we see that optimizing production flow has to dynamically integrate the allocation of these steps, which raises the question of how can we dynamically generate and integrate the schedule that takes all these influencing factors into consideration. This moves us to the proposed work, and first the architecture.